far are we actually reaching into the cosmos today? To answer that, we'll start by looking at our immediate orbital neighborhood, seeing how we're surviving in space right this very second. And then, we're going to push our virtual ship way out into deep space, where some truly mind-bending discoveries are being made. Here is our flight plan for this explainer. 1. Tech powering the future. 2. Return to the moon. 3. Uncovering Martian secrets. And 4. Mysteries of deep space. Section 1. Tech powering the future. Autonomy and propulsion. Okay, so starting close to home, just a few hundred miles up, a seemingly small manufacturing test is actually the key to conquering the cosmos. The European Space Agency and Airbus just successfully 3D printed the first metal part on the International Space Station. Now, you might be wondering, why is that such a big deal? Well, if you're traveling to the edge of the solar system, you absolutely cannot wait months for a supply ship to bring you a replacement wrench or a broken engine valve. This is a massive breakthrough for crew autonomy. It means future long-duration missions can just manufacture what they need exactly when they need it. And that brilliantly illustrates our ultimate goal out here, self-sufficiency and raw power. Look at these immediate orbit updates. NASA is developing a liquid lifeline to literally create IV medical fluids in space, using the water they already have on board. Meanwhile, Astrobotics successfully tested a next-generation rotating detonation rocket engine. I know, it sounds like sci-fi, but it's a radically efficient experimental propulsion system. Plus, we're constantly refreshing our human presence, with Canadian astronaut Josh Kutrick just assigned to the upcoming ISS Crew 13. Whether we're engineering new propulsion, making our own medicine, or sending up new crew, it's all about sustaining human life out there in the dark. Section 2. Return to the Moon. Artemis II mission updates. Leaving our immediate orbit, we are setting our sights 238,000 miles away. As your documentary guide, I can tell you the anticipation right now is palpable. We are going back to the moon. You can see the structured steps coming together for Artemis II. Step 1, the massive Space Launch System rocket core stage just completed a 900-mile barge journey to Florida. Step 2, the Artemis II capsule itself is back at the Kennedy Space Center. All of this hardware is converging for Step 3, launching a crewed lunar flyby. These are the physical building blocks for the first crewed lunar mission in over 50 years. But listen, we aren't just repeating the Apollo days, we're giving the whole experience a massive upgrade. Past missions relied on traditional radio, right? That standard, lower bandwidth comms gave us those iconic, but let's be honest, kind of grainy television broadcasts. Well, for Artemis II, NASA is utilizing a brand new laser terminal. This means high-definition data. It's going to enhance our views from the spacecraft so much that everyone on Earth will get to ride along and see the lunar journey with unprecedented clarity. It is a real game changer. Section 3. Uncovering Martian secrets. Rovers on the Red Planet. Moving further out, roughly 140 million miles away to Mars, our robotic explorers are fundamentally rewriting our understanding of the Red Planet. We have twin sleuths on the surface doing just incredible work, but they're showing us two completely different sides of Mars. The Curiosity rover recently discovered organic molecules never seen before on the planet. That's a massive chemical clue hinting at a watery, perhaps habitable past. On the flip side, the Perseverance rover is our visual powerhouse. It's capturing these incredibly detailed 360-degree panoramas of the landscape, which help us understand the planet's physical formation. Its chemistry and visual geology working hand in hand. And to make sure human explorers can actually get out there and join those rovers, we are fundamentally rethinking how we cross that vast gulf of space. NASA is testing a powerful new lithium-fed thruster right now. Traditional chemical rockets take about 7 to 9 months to reach Mars. This new propulsion tech, it's designed to get us there much, much faster, shrinking the solar system and, crucially, keeping astronauts safer from cosmic radiation. Section 4. Mysteries of Deep Space. Webb, Hubble, and beyond. Okay, finally, we are leaving our solar system entirely. Arriving at deep space, we're peering into the very edge of the observable universe. To really understand what lives out there in the final frontier, I need you to think of space like a giant time machine. Because light has a universal speed limit, looking at something billions of light years away means we're seeing it as it existed billions of years ago. We are literally looking back in time to the dawn of creation. And what are we finding? Scientists have identified what they playfully call little red dots. By combining X-ray data from the Chandra Telescope and infrared data from the James Webb Space Telescope, they've revealed these are actually early universe supermassive black holes. And get this,
Scientists are now theorizing that decaying dark matter might have actually helped create these fascinating, monstrous black holes right at the beginning of time.
And the discoveries out here are just pouring in faster than ever. NASA's SEERX mission is mapping these vast galactic ice regions they're calling interstellar glaciers. The legendary Hubble telescope just turned 36, and it's celebrated with a stunning portrait of the star-forming Tricidid Nebula. We're also learning from new simulations that binary star systems, systems with two suns like Tatooine in Star Wars, might actually be ideal for forming giant planets. But perhaps the most absolutely crucial update here is how we're processing all this data. Artificial intelligence algorithms are now sharpening blurry telescope images, speeding up the James Webb Telescope's data analysis from what used to take years down to mere days. AI is quite literally our new co-pilot in mapping the deep universe. Actually, scratch that. Let's bring our ship back home for just a second. Even as we look deep into the cosmos, untangling the secrets of dark matter and supermassive black holes, NASA Chief Jared Isaacman recently reminded us that we are still debating our own stellar backyard. He said, "I am very much in the camp of make Pluto a planet again." I love that. It's a wonderful, slightly humorous reminder that science is an ongoing conversation. Even the definitions of what's right in front of us are subject to change as we learn more. So what does this all mean for us? Well, it brings us to the end of our expedition today. From 3D printing metal in orbit to laser beaming video from the moon to uncovering the dark matter origins of the universe's oldest black holes, our journey outward is truly just beginning. So I want to leave you with this question to chew on. As we continue to push the boundaries of the observable universe, looking further back in time and deeper into the dark, what will humanity discover next?